Okay, this short video is going to be on how to fill in a unit circle very quickly. And I'm going to start with the degrees. And we know that the positive x-axis is 0 degrees. Then I'm simply going to count by 30s. So I'm going to go with my first angle is 30. I'm going to skip my 45, 60, 90. I'm just adding 30, 120, 150, 180. Again, just adding 30, 210, skipping my half quadrants. Those are 45s. So 240, 270, 300, 330, and then I've made one complete revolution, so 360 degrees. Now I haven't done my 45s yet, so I'm going to do that. So 0, 45, 90, 135, I'm simply adding 45, 180, 225, 270, 315, and I'm back to 360. So the degrees is pretty easy to get on there. Let's do our radians. We should be able to convert 30 degrees. So 30 times pi over 180, that'll be pi over 6. So we know it's 0 radians. This is pi over 6 radians. Now, just like I did with adding 30s, I'm going to count around by pi over 6s. So that's 1 pi over 6. That would be 2 pi over 6. But if I take 2 pi over 6 and reduce it, it's really just pi over 3. So 1 pi over 6, there's 2 pi over 6 reduced. That would be 3 pi over 6, which is just pi over 2. So 1 pi over 6, 2 pi over 6, 3 pi over 6. This would be 4 pi over 6. So if I reduce it, that's 2 pi over 3. This would need to be 5 pi over 6. 6 pi over 6 reduced would just be pi, and that makes sense. This then would have to be 7 pi over 6. That would have to be 8 pi over 6, but I'm going to reduce it. So that's 9 pi over 6. I'm going to reduce it. So 3 pi over 2. 10 pi over 6. Reduced would be 5 pi over 3. And then this would be 11 pi over 6. Doesn't reduce. 12 pi over 6 would reduce to 2 pi. So I counted around. 45 degrees, if we converted it, would be pi over 4. So let's count by that. So 0, 1 pi over 4, 2 pi over 4 reduced is pi over 2. So here's 3 pi over 4, 4 pi over 4 reduced is pi, 5 pi over 4, there's 6 pi over 4 reduced. So this one has to be 7 pi over 4, and 8 pi over 4 reduced. So there are your radians. Now we need to remember back to our 30, 60, 90 triangles. And when we did that, the cosine was root 3 over 2. The sine was 1/2. When we did 45, we got 1 over root 2. I'm going to put it as root 2 over 2 and root 2 over 2. And for pi, or 60 degrees or pi over 3, it was 1/2 and root 3 over 2. Remember, that first number is cosine, that second number is sine. Okay, first number cosine, second number sine. I can label the coordinates of all these points because we always make it a unit circle, which means it's a radius of 1. So this point here is at 1, 0. This point here would be at 0, 1. These are all my axes. Over here would be negative 1, 0. And here would be 0, negative 1. Now I actually know all of my other coordinates because if I draw that triangle like we showed on a previous video, this triangle here is the same as this one right here. So that's going to be root 3 over 2 and 1/2, but since I'm in quadrant 2, the x value needs to be negative. So I can fill in root 2 over 2, root 2 over 2. First one's negative. And then here, this triangle would be the exact same triangle as this one. So I'm going to use 1/2 and root 3 over 2. X is negative. Do the same thing in quadrant 3. This triangle here is identical to this one. So we're going to use root 3 over 2 and 1/2. Quadrant 3, though, both x and y are negative. So that would be root 2 over 2, root 2 over 2, both negative. This triangle with the x-axis is the same as this 60-degree one up here. So that's 1/2 root 3 over 2, quadrant 3, both negative. I do the same thing in quadrant 4. So this is root 3 over 2, 1/2, only y is negative. Root 2 over 2, root 2 over 2, only the y is negative. And this is 1/2 root 3 over 2, only the y is negative. So there's how we can quickly fill in a unit circle.